Let's review what function pointer is. As an example, I've defined the three functions f1, which has a double return type, one integer. What it simply does is return the parameter as is, but that function 2, double return type, one integer parameter, it returns twice the parameter. And just for information, so here the cout is there in between. And another function f3 does a similar thing, but it does not return any value. It simply prints that. Suppose we have three functions, then the function pointer in general C++ is a variable to store the name of the function. That's a function pointer. If you recall, the name of the array is the address of the first element in the array. Similarly, name of the function is a instruction, the first instruction, the address of the first instruction of the function definition. So to store name of the function, because it is address, so we need a pointer. Then how to define function pointer? It goes through a little bit complex syntax requirements. Suppose I want to store in variable p the name of the function f1, for example. So to do so, p has to be a pointer because f1 is the name of the function, which is addressor. So how do we define variable p? Since it is a pointer, C++ requires a star before it. And then we put this p star in parentheses, and then prior to parenthesis opening, we specify return type of the function. So here f1 is double return type, so we give a double prior to that. Then after the closing parenthesis, we have another parenthesis there. In this parenthesis, we list the parameter of the function, int type only. So to define a function pointer, a few things are required. That is a return type of the function, and then list of parameters for the function, which implies in variable p, you cannot store any arbitrary function names. Like f3, you cannot store into p because f3 return type is a void, not double. So in p, all you can store is any function name, like f1, if the function returns double type, and then if the function has one int parameter. So in this example, f2 satisfies that condition. So in p, later you can store f2 if you want. So those are okay. So if I compile the program, we have no problem. But if I try to store f3 in p, it should be an issue that there is a type matching issue is there. So f3 cannot be stored there. So to store f3, you need to define some other pointer. So it's a void return type. The parameter pointer name could be m, and then takes one integer. Then in m, you can store f3. That satisfies the requirements. So if I compile now, it's all good. So in other words, similarly, if I have function 1, another parameter into k like that, then f1 cannot be stored into p because pointer p defines only one parameter int only. So if I try to compile this program, again, this assigning f1 into p is an error. So to do so, you may need to define another pointer, function pointer for that. So once you have a function pointer, you can call the function using the pointer. So here we can call function f1 using p. So p is holding the address. So using star p like a regular pointer notation, you are moving to the location. So in star P, now you are at the function definition. Then you need to provide a parameter for that. So parameter is in parentheses, is an argument call. So to avoid the syntax complexity, so we put those in parentheses, and then we provide arguments call functions. So this is same as F130 call. Then let's display it on the screen using cout function. Then compile the program, run it. Now F1 function is called as we expected. So at this moment, if I give F2, compile the program and then run it, F2 is called instead. So same function pointer is used, but the value in the variable is different, so that function is called differently.